Hello everybody. Hello everybody. How are you all? So welcome to iScholar. So in this session, in the complete playlist, what are we going to do? We are going to solve H.C. Verma capacitor chapter. We are going to solve complete H.C. Verma capacitor chapter in the video series. Okay, so in the first video, we'll be doing 10 questions and similarly, we'll be going further. So each video, you will find a solution for 10 questions. So let's get started, students. Okay, so the first question which is given is which is given as when you have these many electrons are transferred from one conductor to another, a potential difference of 10 volt appears between the conductor. You have to calculate the capacitance of the two conductor system. See, initially the questions are quite simple. They are quite formula based. So let us deal with this. Number of electrons are given, transferred from one conductor to another. Potential difference is 10 volt. Calculate the capacitance. We'll say as we'll use the formula Q is equals to CV. Q refers to the charge appearing, V refers to the potential, and C is the capacitance. As simple as that. Now what is the total charge? These many electrons are transferred. So we'll be saying the total charge will be the number of electrons which we have 1.0 into 10 to the power 12 into charge on one electron. What is the charge on this? That is 1.6 into 10 to the power minus 19 is equals to, what is the value of C? So the C value we need to calculate, and what is the value for the V? So what voltage is given as to be 10 volt. As simple as that. Capacitance will be given as 1.6 into 10 to the power minus 19 plus 12 minus 1. From here you can get the value as 1.6 10 to the power, and that is minus 7 minus 1 minus 8 farad. As simple as that. So the first question was quite simple on the direct formula base. Now coming to the next question of H.C. Verma, it is given that you have a parallel plate capacitor made up of circular disc. The radius of the circular disc are 5 centimeter each. If the separation between the plates is 1 mm, so we'll take it as the separation between the plates, which means D is given as to be 1 mm. What is the capacitance? What is the value of C? We'll be writing it as capacitance value. Again, a very simple formula based question, which is A epsilon naught by D. The capacitance for a parallel plate capacitor is given by E epsilon naught by D. What is E? The area, which will be given as pi r square into epsilon naught divided by D. Right? Now, let me just put all the values and calculate the answer for this. So, pi will stand as 3.14 into the radius, which is 5 centimeter, which will be 5 centimeter radius square epsilon naught, which is 8.85 into 10 to the power minus 12 divided by D, which is 1 divided by 1000. So we just need to solve this value, which will be given as, so from here we can get it as 25 divided by 10 into 3.1 into 8.8 into 10 to the power minus 12. Just trying to ease out with the calculation. So I'm taking this term as to be 5. This would be 2. This will cancel this and will become 4.4. From here I can write the value as 5 into 3.14 into 4.4 into 10 to the power minus 12. Right? So when you will solve something, it is 5 into this quantity. It is something approximately which will come as to be 6.9 into 10 to the power minus 12. What is this? Capacitance. So I'm writing the unit, which is farad. always pay attention whenever you write the value for any physical quantity, just write the units along with it. Again, a very simple question, not much concepts were involved. Coming to the next question, it is given that suppose one wish to construct a 1 farad capacitance. So we want to make a capacitance whose value is 1 farad using a circular disc. If the separation between disc is given as, if the separation between disc is 1 mm, what would be the radius of the disc? Okay, again, we'll be using the basic formula. If we have a capacitance, the formula goes in A epsilon naught by D. A is the area of the plate, epsilon naught being the constant, and D is the separation between them. So capacitance is 1 farad. Area, which will be written as pi r square, which would be 3.14 into the radius, which we need to calculate. So I'm writing r square into epsilon naught, which is 8.85 10 ki power minus 12 divided by D, which is 1 mm. Converting this into meters, so if it is in mm, I will write it over here as to be 1000, which will be divided by this. Now we can just simply solve from here and get the value of r. This r square will become as 1 divided by 3.14 into 8.85 minus 10 ki power minus 12 into 1000. Again, when you solve this complete, you will get something as r square is 10 ki power 12 divided by 10 ki power 3. For easing out the calculation, I'm taking this term as to be 3 itself. This will be 3.1 into 8.85. So roughly you're going to get the value of radius to be 6 meters. When you solve this, roughly the value is coming out to be 6 meters only. Now coming to the next question, again a simpler one only. Coming to the next question, we have a parallel plate capacitor is given to you. Area mentioned. Separation 1 mm is connected to the battery of 6 volt. Calculate the charge flown through the battery. Okay. Let us deal with this type of problem. A parallel plate capacitor with the area which is mentioned as 25 centimeters square. Separation is given as, D value is given as 1 mm. Is connected to a battery whose value is 6 volt. Calculate the charge flown through the battery, how much work is to be done. So how can we calculate? As simple as that. We know that we have a capacitor and the charge flown by the capacitor is given as Q is equals to CV. Q we need to calculate. The capacitance value would be just, we'll be using it as E epsilon naught by D into the potential value is 6. Right? So E is given, epsilon, area is mentioned to you, D is mentioned, potential is mentioned, epsilon naught is a constant, we know the value. We can easily calculate the Q through this. So from here we can calculate the value of this as to be 25 centimeters square. I'm writing the value of this 25 centimeters square. Converting this into meter square. Dividing this by 100 into 100 because we have centimeter square into epsilon naught, which will be given as 8.85 into 10 ki power minus 12. What is the separation? That is 1 divided by 1000 into the potential, which will be something 6. So from here you will get something, the value to be as, this charge value is coming as, when you solve for the complete calculation, it is something 1.33 into 10 ki power minus 12 coulomb. Again, a simpler question, more to the formula based part only. Coming to the next question, we have a parallel plate capacitor and a separation between them is given as 2 mm between the plates. So we have the area as to be, area again same as the previous one, we'll write it as 25 centimeter square. Separation of D is mentioned as 2 mm is between the plates. Now the capacitor is connected to a battery. We have a battery which is connected over here, 12 volt. Find the charge on the capacitor, how we can calculate. Again, quite simple, the same thing what we did in the previous part. Q is equals to C into V. Q refers to charge, C to the capacitance, V to the potential. We'll calculate the capacitance value as to be epsilon naught E by D into the V. Again, every value is given to us. We know the value for the epsilon, for the area, for the D and the potential. Again, when you will put all the values, this charge is going to come as 1.33 into 10 to the power minus 12 coulomb. Once you will do all the calculation. Next part says that the plate separation is decreased to 1 mm. If the plates were initially this much separated, now we have decreased them to half of them. Okay, students, tell me what effect will it create? See, we know that the capacitance is given as A epsilon naught by D. If you are decreasing this D, if you decreases this quantity to half, definitely this means that if you decrease it to half, it means that it will increase to twice. If you are decreasing it to half, it will become 2C, and we can say the capacitance now will become twice as the previous one. Find the extra charge given by the battery. So we'll calculate the charge flown in the second condition. So we'll be plotting it as Q charge flown would be C into V. When you have double the potential, when you have double the capacitor, can I say that the new charge will be also the twice? Why? This quantity is getting twice. So this whole charge will also get twice, and I can say that would be just 2Q. Am I clear? If it becomes twice, so we know the initial charge which is Q, final charge becomes 2Q because the capacitance plate distance is changed, and it is asked find the extra charge flown. So as simple as that, we can write that extra charge flown can be written as the final charge minus the initial charge. The final charge is 2Q minus the initial charge is Q. So I'm writing 2Q minus Q, which would be Q itself. So the Q amount of charge will only flow over here. Make sure, students, in such type of question, when extra charge flown is asked, some people do mistake over here. It is extra charge flown. So final minus initial. Okay. Coming to the next one. Okay. So next we have some different type of problem. So we have 3 capacitors which are connected over here in such a way. The capacitance value are given. You have to calculate charge on all the capacitors. Okay. So first of all, whenever you have such type of question, how you will deal? You will calculate the total capacitance. So can I say that? Or it is very simple also. See, if such type of problem comes, you can calculate the total capacitance. From here you can calculate Q is equals to the Q net total path flowing is equals to the total capacitance into potential. Now, if we look into this case, it is quite simpler. How can we do this? Can you say that all these capacitance are in parallel? As simple as that. See, the same potential is connected to C1, same potential is connected to C2, and the same potential is connected to C3. In all of these, we have the same potential. In this also we have 12 volt. In this also we have 12 volt, 12 volt and 12 volt. So in all of these, it is connected to 12 volt. So the case is simple. We have this capacitor which is connected to 12 volt. I can see that the charge flowing this would be Q is equals to CV. What is the charge? Into capacitance. Capacitance value is given, students, that is 2 microfarad. Into potential. What is potential? That is 12. So we'll be taking it as 24 microcoulomb. Clear? What about this? Similarly, we can do for both of them. So what will be for this? The capacitor value is 4. So we'll be taking it as, again, Q is equals to CV. Charge will be given as the capacitance, which is 4 micro into the potential, which is 12. From here you can get the charge flowing through this would be 48 microcoulomb. Make sure you write all the units along with it. Coming to the third, that is, we have the last capacitor and the value is 6 microfarad. Again, the charge flown here will be Q is equals to CV. The charge will be capacitance is 6 microfarad into the potential, that is 12, which will be given as 72 microcoulomb. So in this question, how easily we got the charges for all of these. Am I clear? Coming to the next, we have 3 capacitor which are having the capacitance value connected in series with a potential 12 volts. So I'm writing it as, there are 3 capacitance. 1, 2, these are the 3 capacitance which are connected to a battery which is 12 volt. The value is 12 volt. The first capacitance is 20 microfarad. Second one is 30 microfarad. Fourth one is 40 microfarad. All the 3 capacitance are connected. Find the charge on each of these capacitors. Okay. And how much work is done by the battery? Okay. So how can we do such type of problem? First of all, in such a type of question, calculate the net capacitance. When I calculate the net capacitance, the figure would become like this. First, I'm telling you the approach and then I'll do the calculation. So this is 12 volt. This is 20, 30 and 40 microfarad capacitors which are connected in parallel as shown in the figure, which will be given as C net. Now what I'm going to do, I'll just say that total charge which will be flowing through there would be C equivalent into the potential V. Now, since they are in series, so try to understand, since they are in series, all the 3 capacitor, all these capacitor are going to have same charge for all the 3. So how will we saying that? So just calculate the value of C equivalent. Whatever be the total charge is going to come, this is the same charge which will be flowing through each of the capacitor. So calculating the C net over here, so I'm writing it over here as 1 by C net is equals to capacitance. Since they are in series, I'll be writing it as 1 by C equivalent, 1 by C1, 1 by C2 and 1 by C3. What is the value of C equivalent? Which will be 1 by C1, which is 20 microfarad, 20, because of C2 that is 30 and because of this which is 40. I'm taking the LCM of all and calculating it further. It will become C equivalent is equals to, this will become as 120, it will become as 6, 4, 3 and the C equivalent, the total charge is coming as 13 microcoulombs. So we got the value for the total capacitance of this. Now calculating the total charge, as simple as that, put it over here. So the total charge value would be given as C equivalent 120 by 13 into micro 10 to the power minus 6 into the potential which is 12 itself. So I'm writing the total charge which will be flowing is 1440 into 10 ki power minus 6 by 13 coulomb. Clear with this part? Now what is next asked is how much work has been done by the battery in charging the capacitor. So work done by the battery will be given as, work done is given as Q into V. What is Q? The charge into V being the potential. So charge value you have, potential you have. So work done would be simply 1440 10 ki power minus 6 divided by 13 into the voltage value would be 12. So now what is your work, what is your task is, the work done, I have done the calculation. You just need to calculate and get the final answer. And everyone will write it in the chat box, the answer for this work done, what will be the value. Coming to the next question. Next it is asked, find the charge appearing on the 3 capacitors shown in the figure. Okay. Again, a task would be first simplify the whole setup. First simplify this as much as you can. So I'm writing this would be 12 volt. Here you have 8 microfarad capacitor which is connected over here to 2 capacitance. Students, these two are in parallel. You can see both of them, this part is also connected to one of the terminal, this part is also connected to one point. Both share the same potential, both are between same potential difference. You can also use this technique. For example, if I say this point to be A, this point to be A, so I'm writing this point will also become A. This same wire with no any passive element, I'll say this point is also A itself. If I say this point to be B, anywhere over here, if this point is B, the whole this is connected to the same potential, same point B. Can I say that these two same capacitor are connected between A and B? These are connected between 2 points A and B itself. So I'm saying this is 8. That is why I took them in parallel. And we know that in the parallel, students, the total capacitance is C1 plus C2. As simple as that, I'll write it as 8 microfarad. Am I clear with this? Now what you have to do? Find the charge appearing on this. Okay, so first I'm taking the total C net. What will be the total capacitance? As simple as that. Now this 8 microfarad and the next 8 microfarad are in series. If they are in series, we'll take it as 8 and 8 are in series. So simply, when 2 identical capacitance are in series, it would be C by 2. You can also get the same answer if you use this. 1 by C1 plus 1 by C2 is equals to 1 by C equivalent. You can also try this. You will get the same thing. You will get the same answer over there also. So C net is equals to C by 2. And the value for the capacitance, for the total capacitance, will be given as 8 microfarad by 2, which will be given as 4 microfarad. Am I clear with this? Total capacitance we got, potential we know, so I'm writing the total charge would be C into V. The total potential capacitor is 4 microfarad into the potential is 12, which will be given as 48 microcoulomb. So what does it say? Try to understand. 48 microcoulomb is coming from here. It is coming from the battery. Now, since they both are in series, can we say that the same 48 microcoulomb will be passing from both of them? From this as well as from this. So we'll have the total charge from here and here. It would be 48 microcoulomb. Okay. So one thing I got that in this capacitor, the charge flowing would be 48, it will be 48 microcoulomb. Now, students, see, from here 48 microcoulomb is coming. Now it will be divided into two segments. Why? These two capacitors are in parallel. Again, these two capacitors are equal. So can I say that if 48 microcoulomb is coming, it get divided into two equal paths. So for sure the charge would also be half. So if 48 is coming, because they are in parallel, because they are equal, so I'll say that half of them will be got by this and the rest half will be got by this. So can we say that in this, the B charge, the B capacitor, the charge stored, the charge flown here will be just half of 48 microcoulomb, and that would be 24 microcoulomb. And what about the C segment? Again, you will say it over here. The charge flown in the C will be also 24 microcoulomb only. So both of them will have the charge 24 microcoulomb. Okay? I hope it is clear. Coming to the next slide. Next question says that you have to calculate the equal capacitance. Okay? Coming to the first part. See, in the first part, can we say that if I say this point to be A, let me just change the ink of this pen. Okay, let me say this point to be A. If this is A, this point is also A and this is also A. Taking this point to be B, something in between, this point would be B, this point will also be B. This will also be B, this will also be B. I'm telling you the point method. Whenever you are confused whether they are in series or in parallel, whether they are in parallel or not, just take a point and point each and every capacitor. So I have pointed this, named this, these two are left. So I took this point as to be C. If it is C, students, automatically this point will also be C and this will also be C. So can we say that I named all the three capacitor and which is like A point and this is C point. And something in between I pointed this as to be B. Although this question is simpler, but the technique I'm telling you will be used in all the further complicated questions also. So these three capacitor, now tell me the capacitance, the capacitors between A and B. The first one, I'll write it as which would be C1. C2, which is also between AB, I'll write it over here as to be C2. This is C1, this is C2. Again, between B and C, we have the one capacitor which is C1. Again, between B and C, we have another capacitor which is C2. Am I clear with this? So now it is very clear to us that these two are in parallel, and collectively they are in series. How can we solve this further? I'll write the capacitance between these two would be C1 plus C2. Since they are in parallel, so I just added them. And what will be the value between them? Again, C1 plus C2, and the value would be over here, would be C. Now these two are in series. Now these two capacitance are in series, and we know that the resultant would be now C1 plus C2 divided by 2. Because they are identical, they are equal, identical in series, I just did C equivalent by 2. Clear? Coming to the next question. Students, if you just clearly look over here, can I say that this is just the repetition of the first one? If it is placed over here, as well as this is placed over here. So I'm using two segments of the same over here. Let us deal with this, how to do this. Okay, coming to the next one, again, I'll be writing it as, see, because of the first one. Now I'm also trying to simplify as much as possible. These two are in parallel. I'm writing it as C1 plus C2. Then they are in series with this capacitance. These two, which are also in parallel, we just discussed. I'm writing it as, this will become as C1 plus C2, which are connected to this point. Again, if I'll go over here, see, these two, similar case, these two are also in parallel. I will write it as, this will become C1 plus C2. Again, these two are in also parallel. We'll write it as C1 plus C2, which is connected over here to the point B and to the point A. Now, so simple to solve. You'll say these two are in series. You can write it as, the capacitance between them would be C1 plus C2 divided by 2. Capacitance between them will be again C1 plus C2 divided by 2. And what will be the total capacitance? The total capacitance will be given as, these two are in parallel. We'll write the total capacitance would be C net. They are in parallel. I will just add both of them, and this is the final result. Am I clear with this? Coming to the next. Okay, so the same question, the same type, the only change is that this time the values are given, right? So as simple as that to do. In the previous one, we saw that, okay, this is the repetition one. Okay, this slide is repeated. Let's come to the next question itself. 10th. So that slide was a repetition. Now coming to the next question, which says that find the charge supplied. Okay, what is the question? See, when you see such type of question, I know most of the students would be confused whether they are in series or in parallel. See students, I told you the point method, how to use it now. Just point it. For example, I just took this point as A. So if it is A, can I say that, students, this point is also A? And if it is A, can I say that this point is also B? A. If I name it another point, that is, I name this point as to be B, can I say that this point will also be B? And this point will also be B? So can we see that these two capacitance are connected between EB and EB? So these two capacitance are connected between the same potential. So I'm saying if they are connected between the same potential, so the C equivalent is given as C1 plus C2, and the value will be given as 5 microfarad plus it will be 6 microfarad, and the value would be 11 microfarad. The total capacitance will be given as this. You have to calculate the charge, which will be given as Q is equals to CV. The charge will be given as 11 microfarad into the potential, which is 10. The value which will be got is 110 10 की power minus 6 coulomb. 110 microcoulomb is the value for the first. Am I clear with this? So as we discussed, we are going to have a series in which we will solve all the HCVMA questions for this chapter, capacitor. So in each video, you will find 10 question solution. So that is it for this video. We'll meet you in the next video. By that, thank you students.